Lenses are the eyes of our cameras. They shape how we see the world on screen. But what's really going on inside these tubes of glass and metal? Today we're breaking down the anatomy of a Cine lens piece by piece. From the glass elements inside to the mechanics that let us focus with precision, and even the optical principles that explain focal length and field of view. By the end, you'll have a clearer picture of how lenses function and why they matter so much in cinematography. Let's dive in. At the heart of every lens is the glass itself. A lens isn't just a single piece of curved glass, it's a carefully engineered system of multiple elements grouped together to bend and guide light onto the sensor. Each element has a purpose. Some sharpen the image, some reduce distortions, and others correct color fringing and chromatic aberration. Lens designers combine different shapes of glass and types of glass to balance these challenges. Crown glass bends light less. Flint glass bends it more but causes color separation. Paired together, they counter each other's weaknesses. Traditional spherical elements are simple to make but can distort edges. Aspherical elements, with more complex curves, help control distortion and keep lens sharper. You'll also see terms like low dispersion or ED glass. These special materials reduce the way the color splits apart, keeping edges clean and free from color fringing. These elements are arranged into groups that move in specific ways when you adjust focus. The whole optical system is designed to project a circular image, the image circle, onto the sensor. If the circle isn't big enough, you'll see vignetting or cutoffs at the edges. Every element added to fix one problem risks introducing another. That's why lens design is always about trade-offs. So when you hear a lens has 12, 15, or even 20 elements, it's not just a number, it's a sign of the careful engineering and compromises that make modern cinema lenses possible. If the glass is the heart of the lens, then the iris is the control valve. This adjustable opening regulates how much light makes it through, and it shapes the look of the image in ways that go far beyond brightness. Inside a Cine lens, the iris is made of thin metal blades that expand and contract to change the size of the opening. The smoother and more circular these blades are, the smoother the outfocus highlights, or the bokeh. The aperture is also sometimes called a stop. The term goes back to the earliest photographic lenses and the Waterhouse stops. Simple metal plates with holes of different sizes restricted light. So how do we measure aperture? That's where the f number comes in. An f number, or an f-stop, is the ratio between the focal length of the lens and the diameter of the iris opening. A 50mm lens with a 25mm iris opening is an f2. A 100mm lens with a 50mm opening is also an f2. Even though the physical opening is bigger on the 100mm, the relative brightness is the same because the light has traveled farther. That's why f-stops are standardized across different focal lengths. But f-stops are just geometry. In real lenses, light bounces and gets absorbed as it passes through multiple elements. That's why cinema uses t-stops. The T stands for transmission. Finally, lens speed. How fast a lens is comes down to its maximum aperture. Anything wider than about a f2.8 is considered fast. A lens that opens to a t1.3 is bright and physically impressive because the longer the focal length, the bigger the iris must be to maintain that speed. Another fundamental piece of lens anatomy is focal length. It's one of the first specs we look at when choosing lenses, but it's also one of the most misunderstood. At its simplest, focal length is the distance from a lens optical center, the rear principal point, to the camera sensor when the lens is focused to infinity. Think of a magnifying glass. When you use it to concentrate sunlight on a piece of paper, there's a point where all the rays converge and burn the paper. That's the focal point. The distance from the glass to that point is its focal length. Modern Cine lenses are far more complex, but the principle is the same. Focal length defines how a lens directs light to the image plane. A shorter focal length, like a 20mm, provides less magnification. A longer focal length, like a 200mm, magnifies the subject more. That's why we call them wide and long lenses. Here's a detail many beginners miss. The smaller the focal number, the bigger each step feels. Going from a 20mm to a 21mm makes a visible difference. At the telephoto end, 100 to 101 barely registers. Beyond the numbers, focal length is about perspective. Wide lenses exaggerate depth and make spaces feel bigger. Telephoto lenses flatten space, compressing the foreground and background. That's the real power of focal length. It doesn't just define magnification, it defines perspective. Focal length sets the stage, but it doesn't tell the whole story. To really understand what ends up in the frame, we need to look at angle of view and field of view. Angle of view is virtual. It's the degree of area captured by a lens and sensor combination. It's fixed for a given lens and imager size. Field of view is physical. It's the measurable height and width of the scene captured at a certain distance, often expressed in feet or meters. Here's where the sensor comes in. Every lens projects the same image circle. On full frame, more of that circle is recorded, giving a wider view. On smaller sensors, less is captured, narrowing the view. To put this in human terms, our eyes have about 180 degrees of peripheral vision, but our main field of vision, where we focus, is closer to 60 to 70 degrees. That's why a 50mm on a full frame feels natural. It approximates the way we see. So, angle of view is geometry, field of view is the measurement. Together, they shape how a lens and sensor translate the world onto the screen. Focus is one of the most critical aspects of lens design. At its core, focusing is moving lens elements in relation to the image plane, so light converges sharply on the sensor. Where you set the plane of focus determines what the audience sees clearly. Cine lenses are engineered for extreme precision. Their housing have geared rings for focus, iris, and zoom, with bold, easy-to-read distance markings. These aren't cosmetic. They let focus pullers hit marks repeatedly and crew swap lenses without re-rigging. Unlike autofocus still lenses, cinema glass uses expanded focus scales. They're marked in small increments, often down to inches or centimeters at close range. This allows exact repeatable focus pulls. Cine lenses also have long focus throws, up to 300 degrees, compared to the short throws of still lenses. That longer rotation allows smoother, more precise pulls. Modern designs often use floating elements or dual focusing cams. These move groups independently to reduce aberrations and minimize focus breathing. Most Cine lenses are internally focusing, so the barrel doesn't telescope or rotate. That makes them far more compatible with matte boxes, filters, and gimbals. Some Cine zooms are parafocal, meaning they hold focus as you zoom. Photo zooms usually don't. Focus isn't just about sharpness, it's about control, accuracy, and repeatability, giving filmmakers the power to place the attention exactly where the story needs. Light doesn't just pass cleanly through glass. Every time it hits a surface, some of it reflects. Plain glass can reflect 5% of incoming light. High index glass reflects even more. The result, lost light, reduced contrast, and flare. Multiply that by a dozen elements inside a lens and the problem becomes obvious. Coatings fix this by applying ultra-thin transparent films to lens surfaces. These layers are engineered so reflections cancel themselves out, letting more light pass through. Modern coatings use multiple layers: magnesium fluoride, silicon dioxide, aluminum oxide. Each layer minimizes the reflections across different wavelengths. The impact is dramatic. More light reaches the sensor, blacks stay deeper, colors stay vibrant. At the same time, coatings help protect delicate glass. But coatings also influence lens personality. Strong coatings create clean, high-contrast images. Uncoated lenses give unique flares, softer contrast, and a dreamier feel. So while invisible to the eye, coatings are vital. They make modern lenses possible and give filmmakers another creative tool for shaping mood and character. Cine lenses are more than just tools. They are the paintbrushes of our craft, with strengths, weaknesses, and personality. Understanding their anatomy gives us control. Embracing their character helps us tell stories that feel alive. And honestly, what we've covered here is just a fraction of what there is to know about lenses. If you want a deeper dive, I recommend the Cine Lens Manual. It's a beast of a book, but it's a wealth of knowledge. If you want to understand lenses inside and out, that's the book to grab. If you found this video helpful, hit like, subscribe, and drop a comment about what lenses you love working with. Let's continue pushing each other to learn, create, and grow as storytellers. Thanks for watching, and I will see you next time.